What is up, YouTube? Welcome back to another episode on Code with Annie. And in this particular episode, we're going to take a look at the execution of the producer consumer problem for the code for which we saw in the last video. So if you have already seen the last video, we can continue looking at this, but if you haven't already, please, I urge you to take a look at the last video because that explains the logic behind the producer consumer problem and the way this has been coded. So if you've already seen that, without further ado, let's get started. So here I have two threads which are going to operate on this producer consumer class, and they're going to invoke the produce and consume methods respectively. So we have a thread T1 which is invoking the produce method, and we have a thread T2 which is invoking the consume method. Now what we're going to try to do is start both the threads T1.start and T2.start basically, and we're going to see how this tries to communicate with each other using the wait and notify protocols. So let's start this application. As you can see, we are producing values 1, 2, 3, 4, 5, and then the consumed value is coming, right? 1, 2, 3, 4, 5. So one thread has produced up to 5 items, and then it called wait basically. Therefore, the producer goes into the wait mode and consumer starts consuming the values one by one. And once it is done, it notifies the producer thread, which wakes up to start performing the actions again. But if you notice, we have only produced 5 values and we have consumed 5, and then the program has basically gone into indefinite waiting. As you can observe, the main is not yet closed. The main thread is still active, but there is some kind of wait that has gone into this application. Therefore, you can see that it's not proceeding to produce more values. Neither is the producer active, nor is the consumer active here. So why is this happening? It's because your T1 and T2 threads, which are overriding the run method, they are only executing this logic once, right? So if you want to keep producing elements again and again, all you have to do is put a while loop here, and while true, execute this logic. So this is a hacky way to do it, but what it tries to imply is while some condition is true, basically here it says that forever true, keep producing. And the same thing here as well. When I say while true, keep consuming. All right, so it's the same thing, but I'm going to execute it n number of times. Now let's try to rerun this application. Let's stop this and let's try to run it again and see what happens now. Produced value 1, 2, 3, 4, 5, consumed value 1, 2, 3, 4, 5, and then the program has to continue. See, produced value 6, 7, 8, 9, 10. Again, consumed value 6, 7, 8, 9, 10. So this goes on happening for forever basically. So this keeps running indefinitely till you reach your integer storage point, which is basically like whatever is the maximum capacity of int, I think 32,000 something. It will keep going on till that point, and it will keep producing and consuming resources, and the list will never go full because we have a max capacity of 5. So after 5, the consumer will empty the list. Again, producer will put 5 elements to the list, and this keeps on happening here. As you can see, it has already reached producer value 25. And then again, consumer is consuming all values from 21 up to 25, right? So this in short is the producer consumer problem, and the way you're seeing this print out slowly, right, is the reason for adding this thread.sleep here. But because if I don't put this here, it will be very fast. Let me show you that as well so that it will be easier. Let me stop this program. Let me comment out thread.sleep from both sides. And I'm not going to give any time for the threads to sleep, so let's try to execute them now. And you can see how fast it goes, and it has already reached some 3 lakh 4 lakh some value, right? Yeah, so that's the reason why I put a thread.sleep there, to slow down the execution, to probably show you what has happened, right? I just stopped the application because it was running too fast. So you can increase this timeout to a suitable value, let's say 2 or 3 seconds also, to see it much more slowly. And that pretty much explains this particular video. And one other thing I wanted to show is in new.runnable, right? You can replace it with lambda. This is a suggestion that IntelliJ gives. If you do that, this is how it becomes. Basically, this piece of code, new runnable open parentheses, gets converted into open close parentheses, single arrow, then open close flower brackets, and you have your logic here. So this is basically an anonymous way of writing the runnable function, because this basically says that this is a lambda expression, and this says that this is the run method's lambda equivalent basically, because the run method is a void method, right? So it takes in no arguments, but it executes some logic here. So I am rewriting that in the form of a lambda like this, open close parenthesis, arrow, and some code block that I want to execute here. Same case here also. New runnable public void run can be replaced with a single lambda. So these are all Java 8 features, and the more you get acquainted with these, it becomes more easier to write functional style code as well in Java. So with that, we are done with this particular video. Hope you liked it. Hope you liked the execution as well. And if you do like this video, hit the like button, sorry, and subscribe to CodeWithAni if you haven't already. And I will see you guys in the next one with some more interesting concepts around threads. Bye bye.